We've calculated determinants of matrices before, but we haven't explicitly described how we do that in terms of minors and cofactors. And this will allow us to take determinants of matrices in dimensions above 2 by 2 matrices. We already did 3 by 3 matrices, but we can do 4 by 4 or 5 by 5. And it only works for square matrices. So what we will do, first we need to know what a minor and a cofactor is because we're going to be finding those. The minor, there are multiple minors of a single matrix. The ijth minor of a matrix is the determinant of the matrix formed by removing the ith row and the jth column. So what that means is I have this matrix. If I'm looking at the minor 1, 2, well here's element 1, 2. I will remove that row and that column and then look at the determinant of what's left over. This should be familiar from when we were doing 3 by 3 determinants. The cofactor is taking that, multiplying it by -1 to the I plus j. So the cofactor, 1, 2, is -1 to the 1 plus 2 times the minor 1, 2. Essentially what this means is we're going to have, if we have a 3 by 3 matrix, we're going to be multiplying by +1, -1, +1, -1, positive, negative, positive, negative, positive. So that's all the cofactors are, taking the minors and then multiplying by those. So the process is to find any column or row of minors. So you don't need all of the minors of a matrix. You just need one column or one row. Then find the cofactors of that column or row by multiplying every other one by -1. Then take the dot product of the original column or row with the cofactor column or row. So here is a very straightforward example. The minor 1, 1 is looking at this, eliminating that, and then, okay, what's the determinant of this matrix? Well, it's just 1. Now, let's look at this. Eliminate what's left. What's the determinant of this matrix? That would be 4. So those are the minors of a single row. Now, we want to take the, we want to take the cofactors of these. So that's the cofactor 1, 1 will still be 1 because with a 2 by 2 it's just going to be positive, negative, positive, positive, negative, negative, positive. So that will be +1, but this one will turn into -4. And now, essentially what I'm going to do is I'm going to take this dot product, this should be called C. I'm going to take that dot product between the cofactor vector and the original vector 9, 2. Now we have 9 times 1 and -4 times 2. Now you'll notice that what ended up happening was we did 9 times 1 and 2 times 4 and then subtracted those. That's the same thing. That's another way of showing why the 2 by 2 rule works. When we did it here, we said, okay, the minor 1, 1 is the determinant of 1, 6, 6, 5. Minor 1, 2 was the determinant 4, 6, 1, 5. Minor 3 of 1, 3 was 4, 1, 1, 6. We can calculate those, and then we're going to take the cofactors. So this will be positive, this will be negative, and this will be positive. And then, once we have those cofactors, we'll take the dot product of them with the original vector. So 0, 1, and 1. And this should match with what you've seen before of determinants. So this will all be 0, minus 1 times 20 minus 6, plus 1 times 24 minus 1, gives us negative 1 times 14, plus 23. Negative 14 plus 23 gives us positive 9 as the determinant. Once we start doing 4 by 4, well, the process is the same. I'm going to find this minor, so the determinant here. I'm going to find the next determinant, so by crossing out this, I'll have this matrix. I'll have this determinant by crossing out from here. And then I'll have a last one by crossing out from there. And that'll be that. So I'll have 4 of these. The cofactor here will be positive, negative, positive, negative. And then I take the dot product with the original vector. So 1, 2, 1, 0. I've written these out so that you're not we're not wasting time. Here's the first minor. The first minor is this. You can double check the calculation. We get negative 8. The second minor is this. We get negative 8 again. The third minor is 8. And the fourth minor is 32. So now that we have negative 8, negative 8, what was it, 8 and 32? Now we're going to multiply those in here with our 1, negative 2, 1, and negative 0. We're going to put in negative 8, 8, and what was it, 32 or negative 32? I forget. Positive 32. Yeah. So then we calculate this, and what we get is 1 times the first minor, negative 2 times the second minor, 1 times the third minor, negative 0 times the fourth minor. Add those up, and we get the determinant is 16.